All right, what we're learning today is how to deal with pressures in LeChatelier type equilibrium equations and reactions. So pressure is different than any other kind of stress that you've dealt with so far. And with pressure, we're doing it different because up to now, everything has been, well, I am going to go and do the opposite, okay? For instance, if I were to put in more water in the equation at the very top, what we've said before is LeChat's reaction is to take the water away. How does he take the water away? By shifting to the opposite side. That's what we've been dealing with before. Now, if I took water away from the left, that would be the stress. So I'm lowering the water amount. If LeChat is going to react, he's going to react by making more water because I took the water out. You make more water by going to the side that water is on. And that would be a shift to the left in the reaction that I have at the top here. Now for this guy, I count up my moles on either side, which I've circled here. Okay, I have 2 moles on the left and I have 2 on the right because I counted this 2 and I counted, and that was the only one on the left. Then I counted this 2 and the 1. Everybody understand why this is 1? If you don't, raise your hand. Okay, whenever you don't have a coefficient, it's assumed to be 1. So I add the 2 and the 1, and I come up with the 3 that's here. Okay, and so now my moles on the left are 2, my moles on the right are 3. Now I can do a pressure problem. So the pressure problem starts right here. The stress is that pressure went down. I took the pressure down. That's from outside. Now LeChat is stuck inside the vessel. And he has got the job of trying to increase the pressure. How does he increase the pressure? Go to the side that has more moles. And because I have more moles on the right side, that 3 up there tells me that we have 3 on the right and the 2 on the left. So the side with more moles is the right side. And that's going to be the shift. Okay? Shift.
Shift, not shift.
Fine. Shift. Now it's good for posterity and forevermore. And that will be what's on the left. Now you've got another situation. The other situation is, what if the moles on the left are 3 and the moles on the right are 3? LeChat can't do anything about it. So if you change the pressure up or down, there will be no shift. You'll just, nothing's going to happen. Yes?
The pressure is up, does that mean that the side with less moles?
If the pressure is up, that's the stress. LeChat wants to make less pressure, so he goes to the side with less moles. Yep, that's exactly what you do. Okay? Any other questions on this one? Yeah.
So if we have the stress down, LeChat always does the opposite of what we do, right?
He will always do the opposite. How he does it is different for our pressure than it was when we were just talking about putting in more of a substance. Okay? Yes?
So the stress is the bigger number of moles?
No.
No, the stress has nothing to do with the bigger number of moles. The stress is what we do. And that could be on the left or the right side. I could choose to change the amount of hydrogen by taking hydrogen out. Or I could put hydrogen in. And that hydrogen is on the right side of the equation. So that determines what LeChat does, because he's going to do the opposite. So hydrogen's on the right. If hydrogen goes up, that's the stress from outside. LeChat wants it to go down. Okay? So And the equation that we have at the top, down, is going to be to the left side because there's 2 moles on the left and 3 moles on the right. Okay? So the hydrogen is, but for pressure, that works a little differently, and we're gonna, and it just so happened that it worked the same way. Okay? If I dealt specifically with hydrogen, then that would move it to the, LeChat would want to move to the left if I increase the hydrogen, because he wants to get rid of it. And in this case, that would be the same as putting the pressure up, because pressure down is going to be to the left, which would be the opposite of what I did in my example. Okay? You can really get this left and right. Don't let you go crazy. Yeah? Okay?
Yeah.
Now, the other thing that's new to you is endo and exothermic. Not terribly new. I mean, before we talked about exothermic as having the heat. Oh, crumb. I have this actually backwards. Exothermic, the heat is on the right. Okay, we got to change this. Okay, now that we got that fixed, sorry about that. Exothermic, the heat is on the right. That means heat is being produced. Endothermic, the heat is on the left. So the heat is actually being put in to make the reaction go. So we have to heat it to make the reaction go. And that's called an endothermic reaction. And these guys, endothermics, let's get this fixed up. Okay, we got to make another fix here. We'll get that right now. So endothermic reactions are the kind that are in cold packs, that they mix chemicals, and the heat from your body is going to be one of the reactants on the left side for the endothermic reaction. On the exothermic reaction, this is like burning something. It produces heat when you burn. Now, in exothermic reactions that are equilibrium reactions, we still have the same thing. The difference is that we treat heat as a reactant for exothermic. Okay, right here, there's our heat. It's a reactant. And on the endothermic, the heat is on the left, and our product. Heat was a product on the exothermic. On the endothermic, heat is a reactant. It's on the left side. Okay, so we're going to treat this heat just like we would. Let's take the endothermic first, down at the bottom, and we're going to treat heat just like we would treat this guy, C2H2. Okay, that's ethane, or ethene, actually. C2H2 and ethene is going to react with the bromine, and it's going to produce the product, which is C2H2Br4. So, as we add heat to the endothermic reaction, and let's see if we can get this down here so you can see something, and cover this up so it doesn't get in the way. Oops. Control Z. Put that back where it was. Okay. Sometimes we drag things that are behind the shade. Okay, so heat now on the endothermic reaction is being treated as a reactant. So, if I add heat to this reaction, what does LeChat want to do? He wants the heat to go down. Now, what do you do? Just like before, this is not new now. Okay, what do you do for LeChat to get the heat down?
You add shift right.
We're going to the side opposite the heat.
Yeah.
In this side, in this endothermic reaction, heat's on the left. So opposite is a shift right.
Yeah.
Okay. Now, let's go to the exothermic. And now we see the heat on the right side over here. And so let's put heat into the, the stress is going to be heat in. So heat is up. What does LeChat want to do?
No.
Heat is down. All right, since heat is on the right-hand side, when we say LeChat wants to go to the opposite to get it down, right? When he goes to the opposite, what is the opposite of the right side? Because heat's on the right, opposite is left. So you see in these two reactions, opposite is opposite. It's an opposite shift. Okay? All right. So that's how we treat exo and endo. So if they say it's an exothermic reaction, which they will do in the sheet that you're working on tonight, the exothermic reaction, put heat on the right and treat it just like any product, because products are on the right side. And then on the endothermic reaction, you can count on the heat being on the left. And that's all you have to know to be able to work those problems. Okay. That's good.